Hello, everyone, and welcome to this Copernicus Marine Service workshop dedicated to the Iberia, Biscay, and Ireland region. My name is Andreia Carvalho. I'm a training officer at Mercator Ocean International, and I'll be joined today by Ergane Fouchet from Noveltis. Hello, Ergane.
Hi, Andrea. Hi, everyone. So my name is Ergane Fouchet. I'm an oceanographic engineer at Noveltis, and I'm very happy to be presenting this workshop with Andrea.
Thank you for being here.
So here is how we are going to work during this workshop. All the information, all the material you need, they are all available on Padlet. We will put the link in the chat. And it's also here if you need. On this website, you will find all the information about the workshop. You will have plenty of videos and the participant manual that explain how the Copernicus Marine Service works. All the tutorial videos of tomorrow's practical session will also be there, the e-learning material as well, and also the use cases, etc. So have a look at the Padlet. We are having this workshop on Zoom. So there's a chat on Zoom, but we will only use it for the small talk, for the questions. So you will be able to ask your questions to all the experts that will present today. We will ask you to use Slido. Again, the link will be sent in the chat. So please, for the question to the experts, use Slido. I think we have a slide later for the Slido. Yes, you can use this QR code or the code to ask your question on Slido. And so here's the program of today's session. So right now we're having the welcome and agenda presentation. Right after, Andrea will present you the Copernicus Marine Service. We will have a presentation from Fernando Manzano for the In-Situ products. And Miguel Jimenez will also be here to answer your questions, or again for the In-Situ products. Then Kerstin Stelzer will present us the satellite observation products, and Alvaro de Pascual Collar will present the model products.
Great. And for our use cases?
Yes, for the use cases, we will have a presentation from SOCIB. It will be a video actually about EBSAR, about supporting emergency response at sea. And a second use case from Guillermo Garcia about the oil spill models.
Yeah, just an update. Instead of Adèle Révélard, we will have Emma Reyes also from SOCIB.
Yes. And then we'll have the user corner and e-learning material available presentation. And finally, a little teaser of tomorrow's session with the Workday 2 program. And so that's it for me. Andrea, now the floor is yours for the Copernicus Marine Service presentation.
Thank you. Yes, so let me jump right into the Copernicus Marine Service. And if you're new here, if you haven't heard about the Copernicus program, this is a European Union's program dedicated to Earth observation and to the monitoring the planet, the state of the environment. There are 6 services in this program, and one of them is the Marine Environment Monitoring Service, or the Copernicus Marine Service, which is dedicated to monitoring the marine environment. All these services, they provide open and free data to all users, and they are focused on different axes, such as land, marine, climate change, atmosphere. So for the Copernicus Marine Service, what kind of data can you find? You can find data related to the physical state of the ocean, such as temperature, speed, current, and this is the blue ocean, how we call it. You can also find data related to the white ocean or the sea ice parameters. And you can find data related to the green ocean or the biogeochemistry part of the ocean. So measurements of phytoplankton and chlorophyll and all sorts of things related to the organic part of the ocean. Where can you access the Copernicus Marine Service and its data? Via our website, the marine.copernicus.eu. There you're going to find an you have to register to have access to the data. And you're going to find an online catalog with all this data and information. There's more than 300 products you can find there. These are products that have been taking into account the needs of the users, so it's extremely user-driven. You will have a very strong user support, which will be available to answer your questions related to the use of the product. The data has the same format, which is very useful. And like I said, it's open and free of charge to every users. So what are the sources of these data sets? They come from model data, in-situ data, direct measurements, or satellite data. Our experts will tell you a bit more about this later on. The data sets also have different temporal coverage and different analysis. And they cover not only the global ocean, but also 6 other different regions in Europe. Besides data that you can find in Copernicus Marine Service, we also provide every year a concise summary of the state of the ocean in our Ocean State Report. We also provide monitoring indicators, which you can download and use in several studies. And we also provide visualization tools, which is the case of My Ocean Viewer, which tomorrow we will be able to watch a presentation about My Ocean Viewer. The Copernicus Marine Service tries to respond to the different needs, and we have identified 12 blue markets where you can see the use of our products from environment, society, or economy. So in our website, you can also find direct examples of all these applications. Today, we're going to have two presentations of 2 applications. So to help you understand our products and how to use them, we have a page and on our website dedicated to the learning material. We also, like I said, we have a strong user support that can answer your questions, support you on different difficulties. We organize trainings like this one and workshops, and we also participate in other courses, hackathons, or other activities to try to show you how to use our products. So if you want to know what are we organizing or what is going on with the Copernicus Marine Service, you can follow us on the different social media accounts. So we are on YouTube, where you can also find previous events and workshops, on Twitter, and of course our newsletter. You can also subscribe to that. Thank you very much for your attention. And now I will give the floor to our first speaker, who's Fernando Manzano. Hello. So you can share your screen whenever you want, and Fernando will tell us more about the in-situ products.
In my presentation, sorry, a little bit, I have to prepare something here. Yeah. In my presentations about the in-situ TAC, I always like to start with this quote by Carl Bunch. And the quote says, without sufficient observations, useful predictions will likely never be possible. Models will evolve and improve, but without data will be untestable, and observations not taken today are lost forever. My intention is to point out that the importance of in-situ data, because prediction models needs in-situ data to validate and also to improve their results through the simulation processes. So it's very important. Sorry. Yeah. Next one. The in-situ TAC goals could be summarized in 2 main ones. The first one is the collection of heterogeneous data, the applicants of quality control procedures, and distribution of the data in a common format in near real time. The commitment is 24 hours, but actually it's much less. The second goal consists of providing reprocessed data in delay mode. Both real-time data and delay mode data can be used for model validation and assimilation. Well, since I started to work in Copernicus, in fact, from my landing in what can be considered its prequel, my Ocean 2, more than 10 years ago, I've always had the feeling of the in-situ tax being a pink monster. With this, I mean, it's a component very different from other tax and MFCs, so within the Copernicus Marine framework. So take this into account. Why? Why are in-situ tax so different? Let me give you some examples, some reasons. To begin, in-situ data are completely heterogeneous. We manage data coming from gliders, Argos, vessels, mooring, HF radars, sailrooms, tide gauges, ADCPs, drifters, which implies managing files with different shapes, because we have time series, profiles, trajectories, and even grids in the case of HF radars that are measuring surface currents. To continue, our TAC has 7 regions. That is the IBI, the Norway Shelf, the Arctic, the Baltic Sea, the Black Sea, Mediterranean, and global. And it has many partners involved, as it's not an easy task to collect this huge amount of data coming from hundreds of providers of many countries. Another difference is that at the moment, our products are not visible through the MyOcean Pro viewer. Although I have to say also that we are working in finding a solution with Mercator, and I'm very sure that it could be very soon. But in the meanwhile, our products can be seen from the in-situ TAC dashboard, as I'll show you later. So, recapitulating, our files are different because we have time series. We have time series, we have profiles, we have gridded data coming from each of radars, we have wave spectra, and we have trajectories. But we have also our own data viewer that could be accessible from MarineData4IBI and the Copernicus Marine website also. And then most of our NetCDF files are created by platform, as you can see here in this example of an NRT product. But there is 2 exceptions, and it's the objective analysis product and the AC Cora and Cora products that are the sea surface temperature processed product. That's the IBI team. It's 2 institutions working in strong collaboration, Puertos del Estado, where I belong, and Nologin, 3 people in each, all together and mixed up. We are working very close one of each other. The functions performed within the team are the technical coordination in collaboration with IFREMER, the management of the wave and sea level multi-year products, the AV operations, and the evolution of the dashboard and the website in collaboration with the HCMR in Greece and SOFIP in the Balearic Islands. And I have to say, and I have to do it, Marta, happy birthday, because it's her birthday today. That's the data flow scheme in the IBI, but it can be also extended to the other regions. Basically, data is acquired coming from different providers, relying on the RUSES, and from other initiatives as EMOTNet, CITATNet, etc. Then data are stored, data are stored commonly in a database where it's performed homogeneous quality control procedures and also validation. Then homogeneous NetCDF files are generated using this qualified data. Then there is a process of synchronization with overlapping regions, because there are sometimes there are overlap, and then we have to synchronize with the files from other regions. And then once we have all the files, then we distribute it through the central dissemination unit. We uploaded them. Then what more? Then the multi-year products that starting with a frozen copy of the NRT products that are stored in the central dissemination unit. Then we apply data validation, scientific assessment, some ocean monitoring indicators are calculated, and then all these OMIs and reprocessed products are distributed again through the central dissemination unit. And in the last row, we have the cross-cutting activities, but I'm not going to go into detail with that. There are two ways to access our data. The first one through the Copernicus Marine Catalog, as Andrea has presented before. But once we select, for instance, the near real-time product, one of them, then you have two options. We can access through an airdrop, but you have to consider that only latest files, the last 30 days, are available, and through the most common way to do it, that is through the FTP, okay? You have a link to the FTP. The second one is through the dashboard, as I mentioned before. It's accessible from our website, the MarineInSitu.eu, and there you can select the station or stations, more than one at the same time is allowed, using the filters that you can find on the left menu. And once you select one station, you can check or the files available, that in fact there is actually direct links to the FTP, or even you can see directly using our visualization viewer, you can see directly the data in charts, okay, in different types of charts, depending on the shape that you're checking. Regarding the structure within the FTP, this is the most common structure in our product. I've taken the EV NRT product as an example. For sure, here you will find the latest folder, the monthly folder, the history folder, and the reference folder is less common, but we are trying to use it more and more. Latest contains the last 30 days of data. Then you have one subfolder per day inside, and inside one file per platform and day. Within the monthly, you are going to have the 5 last years of data. You are going to have one subfolder per platform type. This is the platform types. I'm going to explain to you a little bit later. And within each platform type folder, you're going to have one folder per month. And within it, one file per month and platform. And finally, in the history folder, there's all the available data that we have. The files are organized again by subfolders per platform type. And within it, you are going to have one file per platform in server with all the available data, the whole time series or profile or whatever. Then the reference folder is going to be exactly the same as the history, but only top quality data is going to be inside in order to whatever you need. Okay, but here they are only going to have the best quality data that we have. What more? To facilitate the navigation and finding of the files, mainly for automatic scripts, index files are provided, okay? One per folder. And then in addition, you have an index platform with it's an index with all the platforms included in the product. Let's see what's this index. Here you have an example of the content of one of these files. In this case is the index latest file that is going to reflect all the content of the latest folder. Each line in the index is one file in the folder. Then, for instance, if you want to get, imagine that you want to get all the files containing sea temperature, for instance, you have to look at the fields parameter, the field parameters, and then you have to check if you, for instance, you have temp. Then you are going to know that this file contains temp. So you can process automatically this file in order to get all the files containing temp or sea level or whatever. Or if you are interested in in all the files in some region, you have to pay attention to the geospatial lat and long minimum and maximum in order to get these files. Regarding the file naming, we use vgrams to help to know what's inside the file without opening it. So first part is the region. It could be global, Arctic, Baltic, EV, whatever. Then the second vgram here, the XX, is the file type. I framed because I think it's very important because it's going to define what's the shape of the file. So you have to pay attention to it. Then you have the data file, that data type, so platform type. So here you have the complete list, and I'm going to read it. And then the last part, the suffix is going to say, okay, the code, and then the suffix is going to say the time coverage, if it's a daily file or it's a monthly file or since ever file. It could be considered the key slide, as its name coincides with the name of the presentation. We differentiate two products or families, the multi-year and what we name the multi-year near real time, because in fact it's a kind of a mix. I'm going to explain it now. Multi-year products are extended every 6 months. They are global. They contain delay mode, and data targets only one variable. There's one for the carbon, there's one for the surface height, that's the sea level, one for the temperature and salinity, another one for the temperature and salinity, the objective analysis, that it's an interpolated grid, then one for the currents and one for the waves. And regarding the multi-year NRT products, on the other hand, the products are updated every hour. There are global and regional products. They contain delay mode data, but also near real-time data overall for the most recent period, when delay mode data is not yet available. So you can consider that this product is the best available data that we have. That's delay mode data, and when there is no delay mode data because we don't have time enough in order to validate it, then you are going to have near real-time data. It focuses one or more variables, and then we have regional products, one for each region with an NRT multivariable NRT products, and one for the global. So if you have any doubts, you can check this because it's going to contain all the files. And then we have another one for the objective analysis, but with near real-time data, and one more for currents that are including currents derived from the position of drifters and Argos positions. It's important to say that each product has associated two main documents, a PUM, that it's the product user manual that defines the content of the product and how it's elaborated and so on, and a QID, that's a quality information document to explain the quality procedures applied to the data. In addition to these two main documents, you have all other documents, very important, that you can check in here in our website, internal website, MarineInSitu.eu. There's no need to read the whole slide, of course, but here only mentioning that we are improving our format to be full compliant with CF conventions. In this line, we've realized that most of our data, set in a couple of multi-year products and HF readers, fits perfectly the discrete sampling geometries defined in CF conventions. So the idea is to go in this line, okay, for the future. Another important and quite recent initiative is the MIC working group. That's the Marine In-Situ Collaboration Group. That is a working group formed by different institutions related with marine in-situ data. It's led mainly by the Copernicus Marine In-Situ TAC and MarineData4IBI Physics. And the idea is to be coordinated in the ingestion of the marine in-situ data. Because in the end, although both initiatives have complementary purposes, the source of data is the same. So it makes sense to knock on the provider's doors only once in order to be coordinated in this ingestion, gathering of the data. For instance, this quite new fact is reflected in the citation attribute, saying that our files, and MarineData files also, mentioning that this collaboration and coordinated in the data gathering. So last slide, closing. Within the In-Situ TAC, we are trying to be more inclusive. How are we going to do that? First, being coordinated with our initiatives, as MarineData and all this stuff. We have been doing it forever. Trying to make our data fair, that is findable, accessible, interpretable, and reusable. Extending the metadata contained in our files, but also developing tools and mechanisms to help users to use the data. And finally, pointed out the users, not only the current users, but the potential users, to provide what they expect. In this sense, it can be expected more than metadata. For instance, if you detect that you want more metadata, you can ask for it. Or even if you detect that we are not including some station or some data set or whatever, that's the case, please just let us know, and we're going to do it for sure. And that's all. Thank you very much.
Thank you very much, Fernando. It was a really clear and interesting presentation. We have a few questions for you.
Okay.
Andrea, maybe you can share your screen. Okay, so the first question maybe is more for Andrea than for Fernando, about whether the slides will be available at the end of the workshop.
Yes, they will be available. We will put all the presentations and the recordings of these sessions on the Padlet. We have already shared the link in the chat. So yeah.
Great, thank you. Question for you now, Fernando. What are the oldest in-situ observation we can get?
So you mean, I guess it means the year. We have, it depends on the data type, of course, because for instance, sail runs are very new, so only a couple of years maybe. But we have, from tide gauges, we have sea level data for, I think, the beginning of 20th century. So, but it's true that it's only to be a few data.
Okay.
So it's expected a lot of data from the 90s. We start to have a lot of data.
Okay. Okay, thank you. Next question. I'm not sure how relevant this is in the region, but are there any in-situ ice observation?
Not sure at all. It would be a good question for my Arctic colleagues.
Okay.
So I don't know if Miguel knows about that, but in my case, I'm not sure. I'm sorry.
Okay.
I could respond it later.
Okay, great. Thank you. Are these products, sorry, are these products free and they cover all the oceans?
For sure, they are free, of course, as all the products within Copernicus Marine, but they cover all the ocean. I think that we would like to have more observations. That's because I am emphasizing the first that data not observed today at lost forever, because it's very important to have more in-situ data. But unfortunately, I have to say that they don't cover all the ocean. I mean, we have global observations. There is all the ocean covered, but in some parts we have a lack of in-situ data. Do you understand?
Yeah, it's clear. Thank you for this answer. Next question. Apart from buoys, what are the systems to collect in-situ data and how accurate are they?
Okay, it's measured data, so it's supposed it's real data. And we have buoys, but I already mentioned in my presentation that we also have drifters, we have cargo floats, we have gliders, we have vessels, we have tide gauges, we have even HF radars, and many other, all the platforms that are in the sea.
Can I ask just a question on that? Is there a big difference between the accuracy of all these devices, or is it visible, like a big difference in accuracy?
I'm not sure. I think they all are supposed to be calibrated and to perform good observations, of course, but I don't know how's the difference in accuracy of this. Yeah.
Thank you.
Thank you. Whatever. Which one do you want me to read, Andrea? Okay. So Ruth is interested in nutrient levels, and she's asking, are there time scales, data sets that relate to vertical and horizontal level, please?
Not sure, because it would be, as I mentioned, it's very heterogeneous, the in-situ tag. So maybe our colleagues of the biogeochemical products are more informed than me. So we can ask them in order to respond after the meeting to Ruth.
Okay, thank you. Next question then, at some point, do you have to use the API call to retrieve the data? And if so, do people have to have specific programming prior knowledge?
Okay, we are trying to improve that here. Miguel maybe can answer also, but we are trying to improve our interfaces with the data. So now we are providing this dashboard, but it's maybe more visual, but we also are working, mainly Miguel and Sothip, it's working in an API in order to get all this data. We also have an AirDAP, as I mentioned, that at the moment only contains the latest folder. That's the last 30 days, but we are working in order to integrate also the other data sets, the monthly and the history. So yeah, it's an important concern for us to work on this way, because we understand that in order to have our data more useful, we have to work on that to facilitate the integration and the, yeah.
Okay, thank you for that. Don't know how many questions we take because
maybe...
now we have plenty of questions.
Exactly, which is really good.
Which is
maybe
great.
we can stop for now, and
Okay,
then if we have some time at the end, we can continue.
Maybe a little point about the questions. All the answers, all the questions will be answered afterwards. We will share a sheet in which all the questions will be answered. And also on the Slido, you can upvote some questions. So we probably won't have time to read every question for the next presentations. So don't hesitate to upvote the questions you are most interested in. That's it for me, and we can maybe introduce the next speaker. Thank you very much, Fernando and Miguel.
Thank you, Fernando.
And I think Kerstin is here. Hi, Kerstin. Thank you for being with us today.
So yes, hello everybody. I'm Kerstin Stelzer, and I'm presenting here the one part of the satellite products that are available within Copernicus Marine, which are the ocean color products. I'm the product manager or production unit manager of the high resolution coastal product. So this is one part of these ocean color products. And I will try to give you an overview of the ocean color products, a bit, and how to get them and what to do with them. So you've seen this before. The entry point to all this is always the Copernicus Marine website, and to the products you can go via the ocean products. And here we have a lot of them, so almost 300 products. And from those products, for Earth observations, so for satellite data, we have 163 products. So this is a large number, and sometimes it's also a bit difficult to find what you're looking for. So I think in this case, it's always good to ask. There's always a chat window popping up, so that questions can be asked directly to support team. Within this satellite product portfolio, we have different kinds of satellite data. So the one is the ocean color. This is the topic where I will talk about, because this is my topic, and I know a bit about it. But beside of this, there's also sea surface temperature products, and there's also ocean monitoring indicators. So coming from the products, the ocean color or the temperature, deriving statistics, deriving trends, deriving seasonal behavior. This is also available within the product portfolio. But coming to the ocean products themselves, so there's a team, which is the OCTAC, so the Ocean Color Thematic Assembly Center. And there are products all over global oceans and European regional seas. And different satellite missions are used to derive this information. And they're essential ocean variables that are retrieved from ocean color. I will come to this in a moment. The operational service and production at a global scale and these regional scales comes in different resolutions. So this is always the length or the area that 1 pixel in a product is representing. So we have some multi-sensor products which are in 1 kilometer for the regional seas or in 4 kilometer for global. And we have some 300 meter products, and we have quite newly introduced the 100 meter products, which is concentrated on the coastal area only. So when talking about coastal waters, this is very diverse. So we have a lot of different water types. We have very clear water, we have sediment loaded water, and there are a lot of different ocean colors, so to say. And we have to cover all this with our algorithms to provide for each coastal system the right product coming out of this data. And what do we see with the ocean color parameters? So we have, as said, a lot of different ocean colors, and they are caused by sediments or phytoplankton, which is in the water and which gives the water a certain color by certain absorption characteristics, so that the sensor that is measuring or looking at the water can give us some information of what is in the water by these absorption and scattering processes. And so what we see in ocean color is really the ingredients that have a color, which means the essential ocean color variables are the most important or very important, the chlorophyll concentration, but also the turbidity or the suspended sediment and backscatter information that is provided with the data in the different resolutions just said. When looking into data sets, it might be sometimes a bit difficult to find what you're looking and what where to look at, but the product name already tells a lot. I will not go into this in detail, but this is all documented in a product user manual. So if you have a product and you want to find something, it's always good to look at this product user manual, learn about what the name already tells us and how the products are described and characterized. There are a lot of metadata coming with the products, so a lot of information is there, but it needs a bit of time to get into it. Then there's also documentation about about the quality of data. So each product comes with validation, and this validation is mainly performed with in-situ data. And what you see here is the result for this high-resolution coastal service. So we took all the in-situ data we found along the coast in order to validate our products, and all this is documented in the quality information document, the QID. So this is available for each product, and from the product side, you directly can go to the documentation and then download those as well. Unfortunately, for the Iberian African coast, we have very little in-situ data, but we are always looking for format data, and whenever we find a new source, we integrate it in our validation data set and use it. Coming to some product examples, what you see here is the screenshot of the MyOcean Marine Copernicus portal, where you can include the variables you want to see and the region you want to see and the date you want to see. What you see here is the suspended sediment concentration. This is the range, what we see. So it's from darker blue to whiter blue, and we see some higher values at the coast. And this is 1 kilometer product that covers all the ocean, the Atlantic in this case, and it's derived from multiple sensors. The date that is displayed is the 21st of September 22. And if we zoom into it, we see that we have some, we come close to the coast, but we have some gaps directly at the coast, and depending on your application, on the what you want to investigate, it might be necessary also to go into higher resolution and to cover also the areas that are not covered by the 1 kilometer product, but they are covered by the 100 meter high resolution coastal product. And this is one example, and another example is the Gironde, where we have very high concentration of suspended sediment coming with the river into the Atlantic. And you see here again the 1 kilometer product, and if we overlay it with the high resolution 100 meter product, you see that we see more structures in the coastal waters, and we can go closer or more in the estuary in order to see what happens here. So this is a nice example, and depending on your application, either you need daily coverage and not so much detail, then the 1 kilometer is a very good product. But if you want to go closer to the coast and see more structures or investigate the structures, then the 100 meter product would be the better choice. An example on this, again, it's here the sediment concentration, what you already saw, and then we also have the chlorophyll concentration for the same area. And what you see here, for instance, we have some masked pixels here. This is quality control, because we say if it's so much sediment in the water, we cannot say much about chlorophyll anymore. So we mask pixels that are not valid in our algorithms. And what you see here in this coastal product is that we have only a stripe of 20 kilometers, but covering our European coast with this. Some examples what you can do with it. So what we did here is we are in the same area, Gironde River estuary. We took time series within the estuary and out of the estuary in order to see over time, which is on the x-axis, the turbidity that is evolving over time over the last 2 years. And inside the estuary, of course, we have much more turbidity, as this is very turbid water coming in, and then looking into the outer area, how far this goes to the ocean, and can do this for different rivers coming into the ocean, and investigate how this is behaving over time. Or compare all these river mouths, how they behave in comparison. So this is just to show that we have a spatial dimension, and we also have time dimension. And another application that we do, it's not in the Iberian, but it's in the Baltic Sea, that we can observe some dredging activities and see this also in the data, that the turbidity goes up at the certain day when this dredging happened. But we see that some days after, all the sediment that has been released to the water has disappeared again in the time series. So this is first spotlight to the ocean color products, and as I was focusing a bit on the high resolution, because this is the newest product in the catalog, I would like to summarize a bit on this new product. So it is based on the high resolution satellite data from Sentinel-2, and it's covering this coastal stripe of 20 kilometers, and it's covering the full European coasts, and it's in 100 meter spatial resolution. It's in near real time, which means it's 1 day after the acquisition, the products are in the catalog. But as Sentinel-2, it's not covering each day all the seas. What you see here, this is 1 day, and it's covering always certain orbits where the satellite takes an acquisition, and the next day it's a bit shifted. So it's not, we cannot, on 1 day, we cannot have all coasts covered by this sensor, compared to the coarser resolution, which really cover all waters each day if there's no cloud. And with this, I would like to close this short overview. And whenever you work with the data, we are very happy to receive feedback and suggestions where to improve. And yeah, thank you very much for your attention.
Thank you very much, Kerstin.
Thank you very much, Kerstin. Very interesting presentation. We have a few questions already. If you're happy to answer them, if you could just stop sharing your screen so I could, perfect. And I will share mine now. Should be able to see, yes. Okay, first question. Sometimes the available data, such as suspended sediment, is not complete. Only part of it is available. How do you fill the gap? Are you using interpolation?
Yeah, so there are different product levels, and the one that is not complete is the level 3, which has holes due to clouds or that the satellite did not overpass. And there's a level 4. There are 2 kinds. The one is there's a temporal aggregation, so monthly products are provided. They are gap filled because the gaps are always somewhere else due to clouds. But there is also an interpolation, which is performed by DNUF, which takes the time and space in order to fill the gaps, and this is on a daily basis. But I must say, in the coastal products where it's very much changing, the conditions, the interpolation and gap filling is a difficult topic because we have so much dynamic in the water.
Okay. Thank you. Another one. So about the resolution of the data of Copernicus, I am working with very high resolution data, bathymetry of 20 centimeters, satellite images, 1 meter of resolution. Not sure if I understand the question here or if there's a question. Maybe what is the resolution that you need for coastal or for bathymetry? I'm not sure if it is so much for you, Kristen.
Yeah, no, I also do not exactly know. So,
yeah.
But it's an interesting product, I must say.
Yeah. Okay, another one. Ocean color in open waters is able to, oops, it kind of jumps around, is able to distinguish between hydrocarbons and chemical product traces from tank washing discharge operation, like such as pollution.
Oh. I mean, the thing is, what we see is everything that has a color. And so chemical products, traces, not really. I mean, it's really, it needs to have a color, and we do not have that high hyperspectral information. We just have multispectral bands, and I think for this you really need very dense and very narrow reflectance measurements if there is a color information or absorption information.
Sure. Yeah, exactly.
But I'm not very expert on this topic.
That would be something more for in-situ, I guess, right? For the traces of or nutrients, I would imagine. Not so much with satellites, I guess.
Yeah, I mean, we take always the chlorine concentration as a proxy for nutrients, but of course this relationship is very different in different areas. So it cannot be always one-to-one.
Next one. How is the atmospheric correction applied to the different products? And about L3 products, what are they constituted of?
So the atmospheric correction, it depends a bit on the sensor. What we use for the high resolution is the C2RCC, which is available in Snap, and the Aqualine, which is also an open source atmospheric correction. Other products use the standard level 2 products and take the atmospheric correction that comes with the OLG products, for instance. The level 3 products, they contain different parameters. So they're the reflectances, and they're the chlorophyll, the suspended matter, backscatter, KD. There's also a product on phytoplankton types differentiated. So there's a lot that is there. I don't know if this question is exactly what is asked.
Mm-hmm. Thank you. One last one, I guess. Can I have the same spatial resolution for ocean color along the Brazilian coast?
The Brazilian coast is covered by the global products, and they are available in 4 kilometers only.
4 kilometers.
So these higher resolutions, they are focusing on the European
yes.
and a bit of African coast.
Yeah. Okay. And oh yeah, there's one last one actually. See. Oh, there's actually a lot. Since Sentinel-2 images have resolution up to 10 meters, are there products with better resolution than 100 meters?
No, at the moment not. It's a bit of trade-off. I mean, there's a lot of processing needed for daily products covering all European coasts. And in 10-meter resolution, this would a bit an overkill of production, not knowing which regions are used. And we decided for 100 kilometers to have a trade-off of production cost and energy that is needed for this, and details that are shown. I think this is something that can evolve, and if user requires higher resolution, but then it should be thought about if we go to on-demand processing, because covering all coast in 10 meters does not make that much sense if just 5% of the products are used or of interest. So it's a bit a different concept then behind.
Yeah, okay, see. And now it's really the last one. Do you have any data sets relating to the intertidal zone?
It depends what you mean. It's we have the water quality also in intertidal zones. So if the intertidal zones are water covered, we provide a water quality product. If the intertidals are dry fallen, we mask the pixels. So we cannot say anything about it because we do not have habitats or something like this for intertidal zones. We just have information if it's water covered, because we are focusing on the water.
Is there a need, do you think, to include this sort of information, for example, in the future, to include habitat mapping?
Yeah, I think there are discussions on how the coastal products can evolve and be further developed, and like coastal erosion or sediment mapping, bathymetry. I think those are all discussion points currently ongoing. What should a coastal service include as well?
It's very interesting. Thank you very much for your presentation and for answering all our questions. So now I will introduce our next speaker. That would be Alvaro de Pascual from Nologin. He's going to tell us more about model products from Copernicus Marine Service.
Okay. Well, my name is Alvaro de Pascual. As I said Andreia, I am an oceanographer. I work in Nologin, oceanographic weather systems. And in this presentation, I want to give you a walk for the modeling, EV modeling products. And well, let's start. Well, as Andreia told you before, this is the EV region. It's the region in the Northeast Atlantic, and and it's a region bounded by these latitudes and longitudes. And in this region, there is many oceanographic features. For example, the flows of seawater in the Gibraltar Strait, or also the upwelling systems along the coast in the Iberian Peninsula and the African coasts. And well, the EBMFC is a consortium of different companies and different companies and different institutions, where we are working more than 20 experts from many different fields, for example, physics, mathematics, oceanography, engineering, computer science, and biology. And our mission is to deliver regional forecast for this region. For this, we cover the Blue Ocean and also the Green Ocean. So we provide information for physical and also biogeochemical aspects. And to do that, we use high-resolution models, using also procedures of data simulation schemes. And we also run different systems in analysis and reanalysis mode. And we also have to take in consideration the assessment of the product quality. As I said before, we have 3 different models running: the NEMO model, which is the model focused in ocean physics, the PISCES model with 136 resolution, which is oriented to provide the biogeochemistry information, and also another model devoted to provide the information of waves, the one model with this resolution. So the mission is to change this image of the ocean, this theoric image of the ocean, into this. Well, before I would like to say that these 3 models are coupled between them. We have a two-way coupling between the ocean physics and waves. So the result of the model of ocean, the physics model, influences the result of waves, and vice versa. The results of waves influences the physics. And also we have the forcing of the ocean physics over the biogeochemistry models. So at the end, the objective of this is transform this theoric image of the ocean into this, which is an image of the ocean with 3 dimensions, but not only 3 dimensions. Actually, it's 4 dimensions, because we also include in the time dimension. Well, here you have a quick look of the products, the modeling products we offer. As I said before, we have a physics model, a bio model, and a wave model. And we run these 3 models in 2 different modes. We provide an analysis and forecast and a multi-year product. These are actually 2 different systems, the analysis and forecast. So for each component, for each component we produce 2 different systems, and with different features. For example, here you can see the analysis and forecast systems are oriented to produce information in almost near real time. So they are updated very fast, almost every day, and with high resolutions. So they produce information very fast with the available information, with the available data. And we also produce multi-year products that are focused in a different way. They are more focused in produce the best, the more reliable modeling information. So they cannot be produced in near real time. They have to be produced in delayed mode. So they are produced, since they are produced in delayed mode, they usually have longer time records, very longer time records, and lower resolutions, as you can see here. Well, so the end users many times ask us, what kind of system do I have to use? What is good for me? And the answer is, most of times, the answer is, it depends on your requirements or your interests. Here I have a little comparison between those systems. For example, the analysis and forecast systems includes information almost near real time. It's produced every day. It also produced forecasts, as we will see later, and it also produces information with higher resolutions, but usually they have shorter time records. As you can see here, they produce not more than 2 years of historic catalog. But for the multi-year products, they are produced in delayed mode. This means that they are produced in every year or every 6 months. They have better quality data assimilated. So at the end, the result is more reliable, but they have lower resolutions. Usually they have lower resolutions than the analysis model or the analysis system. And they usually have longer time records. Here, well, this slide is quite striking. I have to confess that, but well, I just want to show here a quick look of the specification of each system we have running. For example, the name of the models and the resolutions, the data simulation schemes, the forcings, that everything. I don't want to bother you with this information, but for those of you who are interested in this information, I would recommend to go directly to the product user manuals. The last slide, I would like to highlight this ID, which is the ID, the identification of every product. So here in the Copernicus catalog, you can locate exactly the product, and in this, under this ID, you can find the product user manuals, where you can find all the specific information of every system. And just I want to highlight the difference in resolutions between these systems. You can see, as we said before, the analysis and forecast systems usually have higher resolutions than the multi-year systems, with the exception of the wave system that has the same resolution for near real time and the multi-year system. Here I show a comparison of, as before, in the same table, physics, bio, and wave models, and the system, the analysis and forecast system, and the multi-year system. The comparison of the timetable of the production of these systems. For example, you can see all the multi-year systems are produced, are updated periodically, once a year or once each, and they are periodically reprocessed, and they are updated every 6 months, and their temporal coverage goes from 1983 up to 2021 included. But for the case of the analysis products, we have they are produced, for example, for the case of physics, they are produced daily, producing a hindcast of 1 week and also 5 forecast days. And well, they just have 2 years of coverage for the last 2 years. In the case of bio, is also produced weekly, but including 10 days forecast, because this one is produced just once a week. And in the case of the waves product, is produced twice a day with analysis and 5 forecast days or 10 forecast days, depending on the run of the day. You can see this is again another difference between analysis and multi-year. Here we have model systems that run almost every day or every week. And here we have systems that are updated once a year or once each 6 months. Well, as most of you will know, the production of modeling products, it has very high consumption of computational resources. So let's say that, one cycle of the physical near real-time forecast of EBI, physical near real-time forecasts, consumes about 1,000 cores for 2 hours, running for 2 hours, and it also produces 1.6 terabytes of information. So if we multiply this by the 25 EV cycles launched every week, you can understand that this wouldn't be possible if we couldn't get access to very high computational resources. Fortunately, we count with the collaboration, with the participation in the consortium of CEDRA, the Centro de Supercomputación de Galicia, which has the Finisterrae, the 3rd generation of Finisterrae machines. And in that machine, we spent every year more than 1 million hours of CPU time, and we produce more than 50 terabytes of storage. Well, since the EBMFC is a service that wants to provide a high-quality service, an important thing that has to be monitored is the reliability of the products, of the delivery of products. Thus, we have to monitor every day the operational production, and we monitor these 4 parameters: the acquisition, the run of models, the validation of products, and the delivery of products. And we also maintain the local service where we manage the EV incidents and respond user questions. Every question you send to the service desk will be sent to us, and we will be very happy to help users answering these questions. And we also manage a few monitoring tools to monitor the proper operations of this workflow. We count with the EV-Troll system, where we can check online if everything is online. And well, let's say that we have committed a 93% of reliability in the delivery of products. And during 2022, we had an average, reliability of 96%. And after the reaching of the new Finisterrae machine, the Finisterrae 3, we reached a reliability of 98%. You can see it's very, most of the delivers are on time. And well, in these cases that we fail, we don't have our on time. Most of times, the problem is some hardware problem, but well, for the end users, I think this is not very useful information. But I think which is really useful for end user is that at the end, most of these incidents where we do not arrive on time are solved during the day. in the same line that of providing a very high quality service, we have to monitor all of our solutions. So we have a system. Well, we do this in three ways. First of all, we have the quality information document, which is a document that you can find it in the Copernicus webpage. It's a document when it is shown all the information related with the quality of every product, of every EBMFC product. We also provide the validation information to the Kemen's validation website, and we also participate with scientific literature. So we continuously provide new papers where we analyze the results of our models and the results of our products. And we also have an internal tool, which is the Narval tool. With it, we can monitor online on time all our solutions, and we compare our solutions with in-situ observations of Homerin, takeout tests, etc. We compare also our solution with remote sensing, and we have this kind of plots where we can check where the model, if the model is doing something wrong, or the skill scores are deprecating in any way. And finally, as said Andreia at the beginning of the workshop, we also participate with the Ocean State Report, which is an annual report of Copernicus annual report, where Copernicus provides annually a view of the ocean oriented to the scientific community, as well as for policy and decision makers. And we also have 4 OMIs online. An OMI is an ocean monitoring indicator. They are kind of, well, they are indicators like any other indicator. Is a statistic apparatus that gives information of the, in this case, gives information, summarized information of the state of the ocean. So we have these 4 OMIs online, so and the end users can download it. We have the 2 OMIs oriented to monitor the sea state, the incidence of storms in the EB region, where we monitor the number of storms and the intensity of storms in every year. And also we have indicator on the maximum significant wave height of the year, where we analyze every year the anomalies of maximum wave heights impacting in the EB region. And we also have 2 other monitoring indicators, the temperature, the maximum SST, which is the same that this one, the maximum significant wave height. These indicators provide the information about the anomaly of maximum temperatures along the year, for every year. And we also have this new OMI, which is the ocean heat content in the EB region, where we compute the complete ocean stored in the EB region, and we analyze the trend of this indicator. Well, we are very close to finishing. I just want to show here that the EBMFC is an evolving service. So we have plans to improve our service for the coming years. I just want to give 2 hints in this regard. First of all, during this year, we plan to implement a new system. We have currently 6 systems running. we will jump into 9 systems for the next year, because we want to include an interim product, as probably many of you will know. An interim product is a product that is in between the analysis and near real-time system and the multi-year system. Is a system that will be updated every month with the best available data at the end of the month. And for 2024, the biggest novelty we plan is to increase the resolution of every product. So every product in EBMFC will be even with the same resolution, even if it is analysis, it is interim, or it is multi-year system, and it will be given also over the same grid. So the grid will be the same for all systems. Well, that's all from my side. I hope you enjoyed this presentation.
Thank you very much, Alvaro. It was a great presentation indeed. We have several questions for you. Maybe if you stop sharing your screen, we will share them, please.
Perfect. Yeah,
Great.
Thank you very much. All right.
Okay, so the first question is, how accurate are these models? Does the accuracy change with time when you receive more data for a given product? NRT2 monthly, etc.
Yeah, well, the answer of how accurate is difficult because it depends in many factors. It depends on there is a variability, spatial variability. Models are not equally accurate in near the coast or in open oceans or in surface or deeper layers. Or I will recommend to this question to go directly to the QUIT document, which is every product has associated the quality document where we make a report of the quality of the all products of all variables. Also, every variable is different, has different accuracy. And well, there he can find all the information of the accuracy of these products. And yes, the accuracy changes with time. There is the uncertainties changes in time. So well, there is a process more easier to be simulated, and there are process not so easy. So well, yeah, the accuracy varies in time. Well, in EBMFC we also, there is a web page, a Copernicus web page, where the accuracy of the products is published in delay mode. I think it's published every month. So every month you can check how was the accuracy of the models and the products in the months before.
Thank you for your answer. The next question is, are you storing the output from the original EB model on the original C grid? And would it be possible to get access to the data if so?
Well, yeah, we stored the original grid because the grid we serve the grid in a regular grid, like long grid, but the model runs in an irregular grid, and yeah, we store that information. Well, I don't know. I would recommend to go directly to the service desk because I don't know how. It depends on Copernicus if this data is accessible. This data is not in the catalog right now, so the way to access this data would be something related with to contact with Copernicus service and get this data for other ways.
Okay, So yes, maybe the user support will have more precise answer on this. Next question, with respect to the WAVE dataset, what is the difference between the ERA5 dataset and the one provided by WAM? What is the time frame in the multi-year package?
Well, what is the difference between the ERA5 dataset?
Yeah, and provided by WAM.
Well, I'm not sure, but as long as I know, the ERA5 dataset is for meteo information. I don't know if ERA5 dataset has waves information. In any case, the WAM, WAM's or wave model or wave system, which uses the WAM model, uses the ERA5 information, the meteo information from ERA5, and it produces the information of waves. So I don't know if this is if ERA5 has wave information, so our waves model is providing this information.
Yeah, okay. Thank you for this answer. Next one, do the near real-time analysis and forecasts include any kind of assimilation of real observations? The near real-time, do they assimilate it? Sorry.
No, it's not forecast include any kind of assimilation of real. Yeah. For example, the case we do not include assimilation, data assimilation in the biosystems, but for the case of physical and wave systems, they include data assimilation of real observations. Well, I don't know if it's okay if we go to the slides I saw before, but in that slide, in the first slide where I provide the specific features of every system, this question can be answered because there is no name for this person, anonymous. Well, so you can go over the presentation and in the slide where are provided the information of all products, the features of all products. This user can see a quick look over the data simulation schemes used, and also the data used for data simulation. And as I said in that slide, if that is not enough for the user, I would recommend to go directly to the user manual, where every feature of the systems is very, very detailed.
Okay, thank you for this answer. We have two questions left. Ruth is asking, what is a SWOODY? Oh, more questions, actually.
SWOODY.
Yeah.
I'm not sure in this context what means SWOODY. I don't know.
Okay. Maybe Ruth will precise her question later.
Yeah.
So again, do the near real-time analysis and forecast include? No, we have answered this question.
Yeah.
Yep, sorry. What model can I use to detect the increase of phytoplankton in Galicia? And would it be possible within estuaries?
Well, this is a typical question from end users. What product do I have to use? and at the end is the same. Clearly, this question, the first answer is you have to use the biosystem, because in the biosystem we provide all the information related with phytoplankton and chlorophyll and oxygen, etc. So you have to use the biosystem, the biomodels, and well, if you want to detect it, it depends in what is the scale in detections you want, because you want to detect the increase of phytoplankton in Galicia. I don't know if you are looking for of you are more interested in a climatic approach, so you want to see any increase of phytoplankton in the last decades, or you are interested in the increase of phytoplankton along the year for seasonal reasons. Well, this is the typical question. For example, for the first case, if you are interested in a climatic approach, I will recommend the use of a multi-year system, because you have longer time records. You have about three decades of data, and you can have make studies of this type. But if you are interested in the variability along the year for seasonal reasons, you probably could use both of them. Probably you could use the analysis, because you have a little bit higher resolutions. And if you are interested in estuaries, probably you will need, or you would be more interested in near real-time or analysis products, because they have higher resolution. So it will be great, better for the applications or the description of processes in estuaries.
Okay, thank you. We won't have time for the rest of the questions. We will have to move on to the use case, but thank you very much, Alvaro, and we'll ask you to answer the questions afterwards. Thank you again. And so we are now having the video, I guess. Yes, from the IBISAR from SOCIP.
IBISAR is a downstream service for real-time data ranking in the Iberian, Biscay Island regional seas for emergency and search and rescue operators. IBISAR has been improved, validated, and promoted in the context of a public-private partnership of intermediate users. SOCIP, a marine research infrastructure and data provider from the public sector, RPS Ocean Science, a downstream consulting company from the private sector, and Axtitenalia, a technological center with expertise on marine research, which is a private non-profit organization. It must also be highlighted the active collaboration from the Spanish Port System and the Maritime Safety and Rescue Agency in this project. As everybody knows, effective response to emergencies at sea needs reliable ocean current predictions and observations. Search and rescue operators and emergency responders need therefore to evaluate the performance of different ocean predictions available in near real time. Addressing the user needs, IBISAR Skill Assessment Service allows the visualization, comparison, and evaluation of model performance in the Iberian Biscay Island regional seas. IBISAR helps users to identify the most accurate ocean current dataset in a specific area and period of interest, thus facilitating decision-making. The service is freely available under registration in ibisar.es. IBISAR has three main elements: the catalog, which collects, manages, stores, and serves a wide variety of data, including satellite-tracked surface drifters, HF radar systems, and ocean models, thus ensuring near real-time data availability in a specific area. The viewer, which is a graphical user interface to visualize the data and to make intercomparison between models and observations. And the skill assessment functionality, which calculates and displays the results of the model skill assessment using user-oriented metrics. How does IBISAR work? In 3 steps. First, the service simulates trajectories using all available datasets. Second, IBISAR compares observed drifter trajectories versus simulated drifted trajectories to assess the ocean model skills. And finally, IBISAR ranks the models based on their performance, considering the average skill score over the area and period of interest as defined by the user. The benefits for the target users of using Siemens data products by means of a user-friendly service like IBISAR are a single access point of in-situ and model data, a regularly updated catalog, a customized access to the information with simplified metadata and user-oriented metrics. IBISAR helps the end user to improve search and rescue and pollution control operations, minimize response time, optimize search area planning, and allocate resources effectively. The benefits for SOSIP as intermediate user are the provision of initial and boundary conditions from parent models for dynamical downscaling, the availability of satellite and near real-time observations for model assessment and improvement through data simulation, the funding for hiring staff and developing new services, visibility of the developed downstream services and of the institution, and also training workshops for identifying relevant products. It has been observed a lack of drifters in coastal areas that could consequently reduce the potential of the downstream service IBISAR. So thus, drifters data ingestion should be promoted, particularly at the coastal area. The refining of the geospatial bounding box and the position on land CUSI tests, as well as the addition of some metadata, could be recommended. The generation and near real-time distribution of scientific added value products are required, such as the distribution of standardized HF-rated gap field data that could help to unlock its potential for the use in several ranking applications, and further development of the HF-rated derived short-term predictions. A higher HF-rated integration into Siemens and further data uptake should also be promoted. The use of the HF radar data in particular and the Siemens in-situ data in general for data simulation and model assessment should be boosted. The integration of user-oriented skill metrics and user-friendly assessment tools are recommended. General comments are fully aligned with the main findings from the Copernicus Marine Service Assessment Questionnaire. Users are requesting to have additional and updated products, more coastal data, added value products, or to ease the data access, visualization, searching, and download. An additional lesson learned could be the need to engage the private sector and to keep promoting the applicability, usage, and uptake to unlock the huge Siemens data potential. We can conclude that SOSIP, as a Siemens intermediate user, benefits from the Siemens data available for more downscaling, assessment, and data simulation, as well as for downstream services development. The Spanish Search and Rescue Agency, as a Siemens end user, need reliable data, skill assessment tools which provide user-oriented metrics. It is highly recommended to engage end user over the entire life cycle of the service. IBISAR, as a Siemens downstream service, complements the decision support tools by providing guidance to the users to select the best available data products as input for their search and rescue and environmental risk modeling applications. Next challenge for Copernicus 2021-27 as a user policy-driven program might consider the evolving user needs, the allocation of a specific budget for progressing user uptake applications, and the sustainability and continuity of assistance services in the long term.
So, yeah, sorry.
No, that's all right. You go for it.
Okay, this video was made by Emma Reyes from SOSIB, and unfortunately she couldn't be with us today. I can't see any questions, but if you have some questions on this day to ask them now or later, we will send them to her and she'll answer them. We can move on to our
next speaker, Guillermo Garcia Sanchez. From CSIC, if I'm not mistaken. He's CMAT. He's gonna present us another use case. The floor is yours, Guillermo, whenever you.
Hello, thank you very much. I'm Guillermo Garcia Sanchez. I'm a PhD candidate working at the Spanish National Research Council in the Mathematical Institute, where my main focus is in studying ocean modeling and also Lagrange transport from a dynamical system perspective. And also, I'm co-founder of the startup Digital Solution, which is a spin-off of that comes from our research group in the Spanish National Research Council, where we provide service for different ocean model challenges. So, well, probably this picture is the image that comes to our mind when we think about the consequences of an oil spill accident. Like, for example, the Prestige in Galicia in 2002, or the Deepwater Horizon in the Gulf of Mexico, or the recent accident, the sink of the OS 35 that happened in Gibraltar the last September. And although these large spill events are not as usual as it used to be, and that is something good, there is still 4.5 million tons of oil that are spilled every year into the sea. And this is mainly produced by operational discharges by vessels. So you can imagine how important it is to provide reliable and precise information to the rescue teams and local authorities in order that they can intercept the spill before it expands and reach the coast. However, this task is quite difficult, as you can imagine, because, well, we have to consider many factors. For example, the initial location, when it happened, its composition, and other external factors like sea currents, tides, winds and waves, temperature, and salinity. So, well, you have to incorporate all these inputs to your favorite oil spill model. There are, well, different options, private options, and also public options. However, something that both have in common is that they require technicians. They require high expertise in order to incorporate all these parameters and their effect in the spill in the injured model. And also, they take hours to process all this information. And although they are good, they are very good providing the chemical evolution of the oil degradation, the weathering, they sometimes fail in reproducing the trajectory because, as I said, it's not trivial at all how you must incorporate all these parameters in your model. So here is where our startup comes, and well, we are very proud to announce that we have become a Copernicus Marine Service use of case, and probably because, well, we are able to make all this process automatic to incorporate all these variables in the model, and also because we are very fast, we can provide the results within minutes, in fact, in less than 5 minutes. And the outputs are very easy to understand, are live movement maps that can be easily integrated in any GIS platform. Also, we have improved the precision in the spill trajectories. So what we have done is to simplify all these complex dashboards that, as I said, they are manual because you have to incorporate all the parameters by hand, and also they are slow to something that is very easy to understand and that can provide the result in less than 5 minutes. So, for example, this is an a test, where we just provide the location when it happened and the amount of the spill, and we return something like that, a live movement map that can be easily integrated in any GIS platform. So, as I mentioned before, we are a spin-off that comes from our research group in the Spanish National Research Council, where we have been studying more than 20 years the dynamic of the ocean. We have performed different tests, and in particular, we have published our three main research cases that are the Oleg Naidenov, the Volcan de Tamasite, and the East Mediterranean accident that happened 2 years ago in the Mediterranean. And well, also for the Oleg Naidenov and the Volcan de Tamasite, we have used the Iberian Biscay Island model. And well, just as something to mention is that the Oleg Naidenov case that we studied was also a use of case of the Copernicus Marine Service. And now I'm going to explain in more detail the Volcan de Tamasite accident. So just a little of context, the Volcan de Tamasite is a passenger ferry that collided with the Nelson Mandela Dike in Las Palmas de Gran Canaria. So this is Gran Canaria Island, this is Las Palmas, and here is the Nelson Mandela Dike. So well, as a consequence of this collision, 2 pipes were broken, and diesel started to pour into the sea. So well, you can imagine all the rescue teams and local authorities started to try to fix the pipes and also dissipate this leak. So in this case, what we did was to analyze the to assess the performance of 3 different oceanic models regarding the transport, their ability to reproduce the event. So for that, we use, well, the first model we use is this A model, that is the Iberian Biscay Ireland model, and 2 other models that are developed by Puertos del Estado and are nested in the Iberian Biscay Ireland model. That is the coastal model and the port model. So, well, here you can see just an example of how they reproduce the event, but of course we didn't just do a particle evolution analysis. We provided a methodology that comes from the dynamical system theory, where using a dynamical system tool that was developed in our research group by Ana Maria Mancho, that is the Lagrange descriptor, we were able to analyze globally how is the dynamic provided by the different oceanic models. Of course, I cannot go into the details, but I refer you to our paper in Frontiers in Marine Science. And of course, if you have any question, I will be very happy to answer your questions. And finally, just to mention that our model in LIDAR solution doesn't stop at oil spills. We have discovered that our model is able to model many floating objects. Like, for example, we have collaborated in a joint project in Galicia with the company GMB and the Universidad de Vigo in order to find the sources of pollution, of plastic and textile pollution that washed up the coastlines of CA Island here in Galicia. And well, for that, we used the Iberian Biscay Ireland model as well, and the results were very, very good. And well, in the following months, we expect to publish the results. Also, we have an active collaboration with the Spanish authorities in rescue and shipwreck situations. And here we have proof as well the performance of the Iberian Biscay Ireland model also in real time. The results were very, very good, as well also the Puertos del Estado model that are nested in the Iberian Biscay Ireland model. And also we have run now successful tests with containers and gliders. And in the following months, we are going to start a project to see how well our model is able to reproduce the trajectory of algae, also using the Iberian Biscay model, Iberian Biscay Ireland model. So thank you very much. And if you have any question, I will be very happy to answer.
Thank you, Guillermo. We have 2 questions, at least for now.
Yes, I will be sharing my screen so you can see the questions. First question.
Do you validate? How do you validate the results of your model?
Okay. Well, for that, we have developed a methodology that is, well, extends the skill score method that typically you use to validate particle tracking evolutions. And well, it's called the Lagrangian descriptor and also the Lagrangian uncertainty quantification. I have some papers that maybe I can refer to you, but of course, it goes beyond I cannot explain in detail all the methodology, but I will be very happy to answer all your questions if you, well, I can provide my email or, yeah.
Thank you. You said that your model work for other things that oil spills. Does it work for missing boats?
Yeah, indeed. Well, we did an example with a missing boat, but the conditions were quite good because the wind wasn't very, very strong. So of course we haven't tested our model in all the spectrum, with different strong winds or small winds and everything. But it seems that, well, we depends of course on the time scale that we are analyzing. For example, if the boat has been missing for more than, I don't know, a couple of days, it seems that with our methodology we can more or less reduce the error on the trajectory or the evolution of the trajectory.
Okay, thank you. How do you include wind fetch?
Well, of course, it depends on the object that we are analyzing, but if the spill is submerged, that is just below to the sea surface, the wind is already incorporated in the Iberian Biscay Island model, so we don't need to incorporate it twice. But if we are analyzing another object where the sail effects are important, of course we have to include it, and it is just depends on the object and the scale that we are analyzing.
Thank you. We already answered this. Is it possible to access your model online? Any registration is required?
It's going to be eventually online, and right now we are thinking inviting people to use our model. So of course, if you, Alexandra, are interested in using our model, maybe we can have a chat and we can give you a premium access to our model just to receive feedback.
Thank you. Another question about the validation. Do you use in-situ data for the validation?
Well, for example, for in-situ data we use or the real location of the object. Like for example, if it is an oil spill, we use satellite images that our colleagues from the Las Palmas de Gran Canaria University provide us the image. We don't have this know-how right now, but also for other objects, it's just the location. This is what we use, the real location of the object.
Thank you. One last question. Maybe do you test your model with any in-situ station? Well, that's kind of the answer you gave.
Yeah, I mean, of course.
That's what you said, yeah.
Mm-hmm.
How much resolution are you using? What of numerical scheme are you using?
The resolution depends. Of course, depends on the model that we are using. For the Iberian Biscay Island model, is typically the resolution of the model, and also we are able to extend a little bit the resolution to describe better some features of the coastline. And I don't know if you know, but the resolution of the EB model is around 3 kilometers. And also we use Puertos del Estado model that are very high resolution, around 300 meters. So, and we can extend a little bit that resolution to see better the dynamics close to the coast. And the numerical scheme, that's something that maybe I can refer you to our papers and you can see that better because it's going to be easy.
Okay, thank you. And so one last question. Can the methodology be applicable to understand sediment transportation by waves in coastal zones?
Well, honestly, I don't know yet because I haven't tested, but we are happy to explore it. So I will keep you tuned.
Thank you. So that's it for your questions. Guillermo, thank you again very much for your presentation.
Thank you very much for the invitation.
We're having the user corner and e-learning material presentation right now by Cédric Giordan. Hi, Cédric.
Hi, Ergane. Hi, everybody. I share my screen, just 2 seconds. So nice to meet you. I'm Cédric. I manage the user support of the Copernicus Marine Service. I'm going to give you an overview of the useful tools and online tools to master the data and the services. So to answer the question asked earlier about the access to the Copernicus Marine Service catalog. So there are 2 different ways to access it. There is an online ocean products on the main page of the website, and you will clicking on it, you will reach the data store with all the different products with on the left side different filters to use and to define your search. And the other way to download this the catalog is through the My Ocean viewer. I'm going shortly because you will have more information tomorrow with Anaïs. I click on Ocean Visualization. You will reach three different viewers, and using the last one, My Ocean Pro, you will reach the viewer tool, and here using Add Layer, you will as well reach the data store with the same filters. So after answering this question, I come back to the main page, and I want to direct you to the user corner in the main menu here on the right. If I click on user corner, there are several boxes. The first one is a getting started box. So I click on it. You will find a sum up of our offer. So it's important to remind that all the downloads, the products, etc., the services are free. And below, operational path to search, to visualize, to download products, to be informed, etc., with useful links included. I come back to the user corner. The second box is a very, very important one because it is a link to the Help Center. In the Help Center, you will find more than 130 articles dealing with several topics for download, of course, the product information, etc. So you will find different collection, an introduction to the Copernicus Marine Service, information about the download, about the visualization and manipulation, etc. And you can use the search to find an article. For example, I click download, I specify download, then I reach this article, how to download Copernicus Marine product. I click on the title, and this is the article. So you will find detail on the different services available for a specific product. So do not hesitate to have a look on this Help Center because it is really, really useful, and it is up to date frequently and by the team. And do not hesitate if you have any question or any comment on an article, and we will answer you shortly. I come back to the user corner. The user notification service. In this page, you will find the list of all operational events impacting a product or a service, or both. So there are 4 different categories. So general, improvements, incidents, and maintenance. So I go to incidents. And for example, there is several in progress incidents. I click on the title. For example, there is a delay regarding the global physical product. And what is important in this section, user notification service, it is the possibility to create and subscribe an RSS feed. So you can create it using the different filters, and you can create the RSS feed, and you will be automatically informed in case of incident of your product. So it's important to know to use this possibility. So the RSS feed, and in the Help Center there is an article to explain how to use this RSS feed and to subscribe. Come back to user corner. The e-learning services. So it is a link to the events regarding the Copernicus Marine Service. For example, a link to the EB training. A link as well to the e-learning materials. In this page, you will find so different material on different tools, so Python, etc. You can use the search area, the filters, to specify your search. So you will find beginner, intermediate, and advanced level articles, materials, different subjects, and different tools. For example, Python, for example, you will reach many information, notebooks, and scripts, etc., to improve your knowledge of the services of the Copernicus Marine Service. The next box is the product quality. Following this link, you will reach a dedicated inserted website about the quality of the products. So here, as it's written, you will find generic information, the quality of the blue, green, or white ocean parameters. So blue for physical, green for biochemical, and white for ice. And you can as well sort on your area. For example, I click on the Iberian Biscay Island and Green Ocean, for example. I have a different information on the quality of the products. I'll let you discover this page and this website. I come back to the user corner. This product brand map, this page announce, so it is under, it is currently under reviewing this page because, so I will go shortly, because in this page you will find evolution for the medium term and long term. So for the moment, it's not the case because it's not updated, but it will be reviewed and updated soon. So do not hesitate to check this section regularly. Sorry, I come back to the user corner. Get inspired. So here you will find all the use cases. There are more than 230 or 40 use cases regarding the service and the products of the Copernicus Marine Service. You can use the filters. For example, if I click on the Iberian region, you will find here, for example, the use case presented before by Guillermo. And so the products used, the benefit for users, the useful links, etc. Everything is available in this in each use case. Come back to the user corner. So this is a link to log in or register. To remind you, it's mandatory to register to download products, but the use and the download is free and it will remain free even if you are registered. So just a few information I requested: first name, last name, email, country, and type of organization, and blue markets. And you register. The registration is automatic, and so you will access to all the products. The service commitment, in this sense, I won't open this page because it's a text to explain how to what are our commitments and what are your obligations on the citation of the products. You will find on everything in this document. And the last one is the contact us form. So to contact the user support, you can use this online form. You can as well send us an email at the address servicedesk.simems@mercator-ocean.eu, and using here on each page of the website the chats, the widget chat with different tabs below. So home, messages, and help. You can here there is direct link to the help center. For example, if I want to check how to be informed of operational events, I click on the title and I have a link to the article. And of course, you can send us a message, and you will meet a member of the team, Anaïs, Martin, Elena, another one. And so if we have the answer, we will answer you shortly. And if we don't the answer, we will find the expert to give you the best answer as possible. So do not hesitate to contact us for any question, and we will be happy to answer you. Thank you very much.
Thank you, Cédric, for this useful information. So now you can all know how to access the Copernicus Marine Service, how to download our products. Thank you very much. And so we are getting to the end of this session today. We will have one last, bye Cédric. We'll have one last speaker. It's going to be Alexandre Homerin, the Noveltis, and he's going to tell us a little bit more about tomorrow's presentation. Tomorrow we'll have a practical session, and the floor is yours, Alex.
Hi, thank you, Andrea. So hello everyone, I'm Alexandre Homerin from Noveltis, and I'm going to briefly introduce you to tomorrow's program, so the second day of the workshop. So you have practical sessions where there will be exercises with QGIS and Python. So you will have a first beginner tutorial on Python where you will learn to open the Copernicus Marine Service products, which are netCDF files. You will learn to open them with Python and create basic maps, plots, and do basic manipulations with the data. You can go to, yes. And you will also have an intermediate presentation with Python where we will do a more focused study on wave data. And here you will learn to do some more advanced manipulations. So compute graphs like the one you see on the screen to monitor seasonality of the wave data. We also have the opportunity to compute several indicators for example, extreme wave episodes. So we'll see that tomorrow. You can, yeah. So you will also have a presentation on the MyOcean Viewer interface that will be given to you, also for Copernicus Marine Service products. And finally, you will have presentations on you have a QGIS tutorial. Just like with Python, there will be a beginner tutorial and an advanced tutorial. In the beginner tutorial, it will be also about opening netCDF products using a dedicated plugin for QGIS that we have developed. We learn to display data, display vector fields, and create animations. And in a more advanced tutorial, you will have a case scenario in which you will study the 2022 heat wave that happened in Europe. So there will be more advanced manipulation with QGIS, which will be about extracting data at defined points or defined areas and perform several calculations. And yes, one more thing, you will have all the information you need on the Padlet. I think you already have the link, so they should give you enough material to do the exercises.
Yes, thank you, Alex, for showing us a little bit more of what we're going to find tomorrow session.
Thank you very much.
And we see you tomorrow, I guess. So thank you, everyone. It's the end, Ergane. This was,
Yes.
I guess it was super quick. I don't know. It was my feeling, at least.
Seems fine. Yeah, so thank you to all the participants, all the people who attended this workshop. We really hope you enjoyed it. And mostly thank you to the great lecturers. They provided very interesting presentations. And so,
Yes,
yeah, don't miss tomorrow's session. We will have more practical exercises and we will learn how to manipulate the products that have been presented today. So, yeah.
Yeah, I think that's it. We can, yeah, don't hesitate to continue posting your questions on the Padlet. We will try to answer them later on.
Yeah.
And we'll see you tomorrow.
See you.
Thank you, everyone.
Bye.
Bye-bye.